Hello everyone, welcome to my channel again. We are going to start jam question paper solving and we'll go 5 questions each time and I'll be solving only the organic questions. So we are starting first with the year 2020. So the first question says, from the radical chain reaction below, the correct classification for step 2 and 3 is respectively. So we are having three steps here. First, bromine is reacting with some metal so that bromine radicals are formed and metal remains as such. And then bromine reacts with H2 molecule to give you HBr plus radical of hydrogen, and then radical of hydrogen reacts with Br2 to give you HBr plus Br radical. What it is asking is step 2 and step 3, what are they? Are they chain propagating? Are they chain propagating and chain terminating? Or chain branching and chain terminating, chain propagating, propagating, or chain branching. So the thing is, in a chemical reaction which involves radical mechanism, it involves three steps. First is chain initiation, then chain propagation, and then chain termination. So what is chain propagation? So if a reaction has to happen, first a radical has to be formed. So how radical will be formed? Radical will be formed from a neutral molecule. So you can see in the first step, bromine is there which is interacting with metal and breaking up. So bromine was like that, it interacts with metal, metal weakens the bond and one of the bromine takes this electron, one of the bromine takes another electron and it gives you two bromine radical, right? So this is the chain initiation. So very clearly step 1 was chain initiation. Now what is chain propagation? In chain propagation, a radical is there which interacts with another neutral molecule to form another radical. So what happens is, already a radical has been formed in initiation and you don't want the radical to be stopped. So radical continues to form more and more radicals. So the reaction keeps proceeding. So here in step 2 you can see this Br dot which was formed is reacting to H2 and give you H dot, right? You are giving H radical. Similarly, step 3 also again H radical is reacting with another molecule of Br2 and give you again Br dot, so that again reaction keeps on propagating. So both step 2 and step 3, they are chain propagating steps. So the answer will be C. The final step is chain termination, where something like this one bromine interacts with another Br dot and gives you Br2 molecule, something like this. So this comes and interacts with this comes and interacts with this and gives you Br2. So with this what happens? The radical is consumed and the radical gets consumed, no more radical is there for further propagating. So this is called as chain terminating reaction, or something like H dot would have reacted with Br dot to give you HBr. So in this step 1, 2 and 3, there is none of them are chain termination step. Okay. Next question is, the nucleobase not found in DNA is. So we have to know that in DNA we have ATGC, adenine, thymine, guanine and cytosine. Whereas in RNA we have adenine, instead of thymine we have uracil. Just this is the difference between DNA and RNA. So you have adenine, uracil, guanine and cytosine. So the answer is B, that is uracil, right? The next question, the correct statement for the following structure is. So you are having these three molecules and they are asking, are they resonance structures or some of them are isomers, or what it is. So first let's understand the resonance structure. What happens is pi electrons and lone pair moves. So here molecule is neutral. If at all something moves, you should be getting some negative charge on one of the nitrogen and positive charge on one of the nitrogen. So that those would have been minor contributor, but these are all the resonance structure possible. So very clearly here electrons are not moving when it is coming from 1 to 2. What is happening here is, if you look at it, what is happening here is you are having alkene CH bond and then NH single bond. So this nitrogen is sp3 hybridized with lone pair and it is having single bond there next to each other. And then we have C double bond and N double bond. Here also if you see, you are again having C double bond and N double bond and But this alkene CH and NH, this saturated nitrogen hydrogen bond, they are at position number 1, 2 and 3. Position 1 and 3. Here it was at position 1 and 2. And here you see it becomes CH2. So what happens is, what is isomer? Um, Constitutional isomer or the structural isomer, they are specific types of isomer that share same molecular formula but have different bonding atomic organization and bonding patterns. So you can see that bonding patterns are different. So all of them are constitutional isomers. Right. Question number 4. The correct order of boiling point of compounds 1 to 4 is. So we are having these molecules 1, 2, 3 and 4, and they are asking uh, in the descending order of boiling point. So let's see what are the different functional groups. So group 1, you can see it is alcohol. Group 2, it is ether, R, O, R prime or R. Okay. So this is ether. So you are having alkyl chain, oxygen, alkyl chain. And then you are having another alcohol, then another alcohol. So first let us differentiate between the functional groups. So the functional group, what it says is, if OH is there, that means it forms hydrogen bonding, and hydrogen bonding forms very strong intermolecular attraction. What happens is, basically O and H, oxygen is way more electronegative than hydrogen, so it pulls the electron towards itself. So oxygen has lot of negative polarity and hydrogen has lot of positive polarity. So what happens when next molecule comes? So H interacts with this oxygen, another molecule will react with this oxygen, interact with another oxygen, and this part. Okay. So alcohol is there. So that's how intermolecular interaction is very strong. And apart from all this covalent ionic bond, coordination bond, no, the hydrogen bond is the strongest intermolecular bond. They hold molecule very close to each other, and therefore it's tough to push them apart, to separate them apart, so that they go off as vapor. So you need more and more energy, and therefore generally alcohols will have higher boiling point when I am comparing it with, when I'm comparing with ether. Ether, what happens? You have oxygen which has lone pair, and oxygen is more electronegative than carbon. But the difference is not as much as between difference between hydrogen oxygen when I'm comparing with carbon and oxygen. So what happens? So because this difference is not there, so the interaction between ethers is dipole dipole interaction. So here it has positive polarity and this one has negative polarity, something similar to that of hydrogen bonding what we discussed just now, but attraction is not so strong, and therefore diethyl ether, boiling point will be something like 35 degrees Celsius, and whereas this will be quite high boiling point when I'm comparing this with alcohol. This should be close to 100. So very clearly this will be last. So we can look at the answer, because all of others are alcohols. So we can see last two. So this can be one of the answer, and this is only a possibility. But let us look at 1, 2 and 3 also. So 1 is a straight chain alcohol, whereas 2 and 3 are branched alcohols. Between straight chain and branched alcohol, straight chain has higher boiling point. Why? Because if imagine another alcohol molecule comes, it stacks over each other much better. So when it stacks over each other, van der Waals force of attraction between them increases dramatically, because they sit over each other very well. So always linear, same thing like linear alkanes also. Linear alkanes will have higher melting point, higher boiling point than branched ones. So very clearly one has higher boiling point. Okay. Now let's compare. Uh, so one thing is very clear: one will have highest boiling point, and fourth will have, second will have last. So C looks to me right till now. Now let's compare between 3 and 4. So you see here there are only 3 carbons, whereas here there are 1, 2, 3 and 4 carbons. So whenever bulk increases, whenever the number of carbon increases, van der Waals force of interaction increases. Van der Waals force of interaction is something like gravity. As the mass increases, gravity increases. Same way at smaller scale, van der Waals force of interaction increases. So 3 should have higher boiling point than 4. So here again you can see 3 is having higher boiling point than 4. So very clear cut answer is C. Okay. Moving to the last question, the amino acid with R configuration is. So here what you have to understand is all these molecules are in Fisher projection formula. So what is Fisher projection formula? In Fisher projection formula, when you show in a two-dimension a three-dimension molecule, what it means is this this vertical line is away from the viewer. It is still tetrahedral. This is the chiral carbon, and you are having this up and down bond away from the viewer, and this horizontal bond which is is towards the viewer. So it is tetrahedral. It is tetrahedral where where the horizontal line is toward the viewer. It is something like two V's. So one V is like this, another V is like this, but perpendicular to it. Okay, so the two V's are perpendicular to it. So it is the same thing what you have done here. So here it is one V. So these two are coming out of the screen and these two are going inside the screen. Now for giving absolute configuration, the lowest priority has to be away from the viewer. So how do we give lowest priority? We give according to CIP rule, which we'll do right away. But before that, what I'm trying to say is whichever is the lowest priority, I will explain you in a zip, but hydrogen is the lowest priority. So the hydrogen has to be away from the viewer. So hydrogen can be either up or can be down, because both up and down are away from the viewer. So if hydrogen was up or down, then whatever absolute configuration we are getting, absolute configuration will depend upon the three-dimensional species arrangement, not rearrangement, arrangement. Okay, so we'll see how it is. But the thing is, we have to see the three-dimensional spatial arrangement, and the lowest priority, that is hydrogen, should either be on top or bottom. It should be on the vertical line, and then whatever you are getting, that will be your answer. But here if you see, all the hydrogens are on the horizontal line. It is always on the horizontal line in all the four molecules. That means they are towards the viewer. So what we can do simply is, whatever priority I am getting, I will write opposite of it, because it is towards the viewer, right? Now let's talk about CIP rule. So what CIP rule says is, we have to give priority to the substituents, and then if the spatial arrangement of these substituents according to the priority given according to atomic number, if they are going clockwise means like this, how we write R. Okay, if it goes clockwise, then it is R, and if it goes anti-clockwise like how we write S, okay, like this, then it is S, right? Then how do we give priority? We give priority according to the atomic number, and we go bond by bond. So let us see each of them. So whatever I am saying, I have written here all this. So let's go at molecule this. So here if you see, this is the chiral carbon. We have to talk about absolute configuration of this chiral carbon. So we see the first bond. First bond here is hydrogen, which has atomic number 1. Here first bond leads to nitrogen, which has atomic number 7. Here the first bond leads to carbon, which has atomic number atomic number 6, and here also it is carbon, which is atomic number 6. So very clearly nitrogen has the highest atomic number, so this NH2 gets first preference. Now hydrogen has atomic number least, that is 1, so it will get the least priority, that is 4th. Now the fight is between 2 and 3. So we don't know COH is 2 or CH2 CH3 is 2, because first bond from this chiral carbon leads to carbon both up and down. Now what happens if you see COOH? If you see COH, COH is attached to oxygen and one OH. So when it is it is attached to double bond oxygen and one OH. So in CIP rule, double bond is considered as two bonds. That means carbon is attached to two oxygen atoms. So carbon, I am attaching it to two oxygen atoms. And it's not that only carbon attached with oxygen with double bond. Oxygen also attached double bond to carbon. So one of the oxygen, I have to draw another carbon, so that I am showing this oxygen is attached to two carbon atoms, and then it is OH. So what happens in the first bond, clarity did not come because both of them were carbon. So we go to the next bond. When I go to the next bond, what I find is oxygen, oxygen, oxygen. So this carbon attached to three oxygens. Whereas when I come to here, first bond was carbon, second bond was leading to one hydrogen, another hydrogen, and another carbon. So we don't need to look at the atoms with the lower atomic number. We have to look at the atom with the highest atomic number. So the highest atomic number attached here is carbon, which is atomic number 6. Whereas here the highest atomic number attached is oxygen, which is atomic number 8. So hands on, COH wins. And therefore the second priority comes to COH and third priority goes to CH2, CH3. Okay. Now what happens? Now this is the priority 1, 2, 3 and 4. Now we have to see the arrangement of only 1, 2 and 3. Is it clockwise or it is anti-clockwise? Okay, we don't look at fourth priority. So we are looking only at 1, 2 and 3. So 1 is here, 2 is here, 3 is here. It is going clockwise. That's how we write R. It is clockwise. So when it is clockwise, we know it is R. So when it goes absolute configuration, when it goes clockwise, it is R. When it goes anti-clockwise, it is S. Okay. So it goes clockwise, so it is R. But answer will be S because we saw that hydrogen is on horizontal plane. It should be on vertical because vertical away from the viewer and hydrogen is toward the viewer. We want the lowest priority to be away from the viewer, but since it is toward the viewer, so it will be opposite. So very clearly this is S. The question was which has R. Okay. Moving to option B. So option B, you are having this. So very clearly again, NH2 gets first priority, hydrogen gets fourth priority, and we look at this. So this is carbon COH. So it is carbon attached to two oxygen, sorry, three oxygen, and oxygen also attached to one carbon. So first bond was carbon here, second bond is attached to three oxygen. Okay, so the highest atomic number is oxygen. When I come to here, this is very interesting. So here it is carbon. Now this carbon is attached to two hydrogens. This carbon is attached to two hydrogens and sulfur, right? We don't bother about hydrogen. We always look at atom with the highest atomic number. So the highest atomic number is sulfur, whose atomic number is 16. Here the highest atomic number was oxygen, which was 8. So hands down, this will win. This will get second priority and this will get third priority. You don't look that this carbon attached to three oxygen atoms. Here it is only one sulfur. We don't look all this. We just look at atom with the highest atomic number. So the highest atomic number very clearly is sulfur. So sulfur wins. So it is like this. So now we will see the arrangement. The arrangement is 1, 2 and 3. Arrangement is going like this. So it is what it is. It, it is anti-clockwise. So it looks like S, but it will be R because H is on horizontal line. So this was the question. So very clearly second is the answer. We'll just look for our satisfaction third one also. So again here this gets first preference, this gets fourth preference. Here COH, so carbon attached to three oxygen we saw, and here excuse me. So here carbon attached to two hydrogen and one benzene ring. So what is benzene ring here? It is carbon. So it is basically attached to two hydrogen, one carbon. Okay, so carbon has atomic number 6, oxygen has atomic number 8. So this wins and this one is third. So again looks like R. So it will be S. Okay, let's look at the fourth also and we'll finish with that. Fourth one again, this get first preference, this get fourth preference. So here is carbon attached to three oxygen, here carbon attached to two hydrogen and one carbon. We need not look at sulfur because we are always going bond by bond. Please remember this, we are going bond by bond. I cannot move from second bond to third bond. I'm just seeing second bond. Second bond is one carbon, one hydrogen and another hydrogen. I will not go to third bond because second bond only, it's very clear this guy is winning. So COOH wins and this one loses, and therefore we give the preference accordingly. So let's give the preference. So you are having 1, 4, this was 2, this is 3. So it looks like R, but it will be S. So the answer is B. So that's it for today. Thank you very much.